We're now going to look at calculating the domains for some functions. Now we've discussed this before in class, but really in only one aspect. We've talked about determining the domain when you have a rational expression and you have to make sure that you never have a zero in the denominator. Matter of fact, I'll do an example of that kind of problem. So let's look at this function, x plus 1 over x cubed minus 4x. So this is a rational expression, and if I'm going to find the domain, I have to basically answer the question, what values of x make the denominator equal to 0? Because whatever those values are, those cannot be part of the domain. The domain is going to be all real numbers except the numbers that cause the denominator to equal 0. So I first have to factor that denominator. I can factor out an x. I get x squared minus 4. And then I realize that's a difference of squares, so I can factor some more. And I get x times x plus 2 times x minus 2. So, here we go now. Let me make a point now. This numerator, this x plus 1, means nothing, does not impact my domain. All I'm going to do is look at the denominator. And in the denominator, I actually have three factors. I've got x, and the parenthesis x plus 2, and the parenthesis x minus 2. So my concern is what value of x would cause any one of those factors to be equal to 0? Well, I know for the first factor, it's x, therefore I know x cannot be 0. Because if x is 0, this factor of x equals 0, and then I've got my denominator equal to 0, which I can't have. The second factor is x plus 2. What value of x would make that parenthesis equal to 0? Minus 2. So I know that x cannot equal minus 2. And then my third factor is the parenthesis x minus 2. I know for that x cannot equal 2. So there are three values of x that are not in my domain. In other words, there are three values of x that will cause the denominator to be 0. So one of the easiest ways to write the domain would say the domain equals all real except 0, -2, and 2. That's a very simple way to write it, but that's perfectly fine. Now let me also do the second kind of domain problem that we have. So the first kind of domain problem is you have to be worried about whenever you have variables in the denominator, just like this problem. But the second kind of domain we have to think about are when we have square roots. So let's look at this problem. F of x equals 8 minus 3x. What do we know about square roots? We know, if we're talking about real numbers here, that we can never take the square root of a negative number. So when we're talking about the domain says, what are all the possible values of x? What values can x be? Well, in this case, I've got to make sure x is never a number that would cause the expression under the square root to be negative. Whatever x is, I have to make sure 8 minus 3x ends up being a positive number or 0. So how would I say that? Well, what needs to happen is, so this thing right here needs to be a positive number, or it can be 0, but it cannot be negative. So how can I determine what values of x? Well, how about I take the expression under the square root and I say, you know what? This thing has to be greater than or equal to 0. What am I doing here? This is a way of saying the expression under the square root has to be positive number or 0. And I'm going to now solve for this x, and that tells me what x has to be for this square root to be okay. So I'll subtract 8 from both sides. Now to solve for x, I'm going to divide both sides by -3, which I can do, but remember, I'm now going to flip the inequality. So I end up with x less than 8/3. Now just to make that clear, let me go ahead and just draw a quick number line. 8/3 is like 2 2/3. So it's about right here. And it says x less than or equal to 8/3. So if I draw the graph, less than or equal to looks like this. What I'm saying is, this is my domain. That's the interval that x's can be in order for the expression under the square root to be positive. If I picked a value to the right of my interval and I plugged it in to my expression, I would end up with a negative under the square root. So therefore, I say my domain is from -infinity to 8/3 with the bracket. So once again, let's review what we're saying here. I'm trying to figure out what values of x would be okay to put into this expression. So I said, well, I know the expression under the square root has to be greater than or equal to 0. It has to be a positive number or it can be 0. So I say 8 minus 3x greater than or equal to 0. I solve for x. I get x less than or equal to 8/3. Then I graphed it, and then I drew the interval. So this domain says the okay values of x are anything between -infinity and 8/3. If I choose a value of x outside this interval, then I'm going to end up with a negative under the square root. So that's a couple of problems on calculating or figuring out the domain.